Think about a piece of gold you own. A ring, a necklace, a coin. That metal didn't just come out of the ground. It was born in one of the rarest and most violent events in the universe, the collision of two neutron stars. These collisions, called kilonovas, are the true factories of gold and other heavy elements. Today, we'll break down exactly how that happens. For decades, scientists knew that stars create elements through fusion. Light elements like hydrogen fuse into helium, helium into carbon, and so on, all the way up to iron. But there's a hard stop at iron. Beyond that point, fusion consumes more energy than it releases. So where did elements like gold, platinum, and uranium come from? For a long time, the answer was assumed to be supernovae, the explosive deaths of massive stars. Supernovae are powerful and neutron-rich, and it made sense to think they could produce heavy elements. But simulations told a different story. Even the most energetic supernova models couldn't account for the abundance of gold and platinum we see in the universe. The math just didn't work out. There was too much gold in galaxies like ours for supernovae to explain. This set up one of astronomy's longest-running mysteries. What event could possibly generate enough of these elements? Where was nature hiding its true gold factory? The breakthrough came when astronomers turned to neutron stars. These are the collapsed cores of massive stars that went supernova. Imagine taking more mass than our sun and compressing it into a sphere only about 20 kilometers across, the size of a city. A teaspoon of neutron star matter would weigh billions of tons. Sometimes, two of these stellar remnants end up orbiting each other. Over millions of years, they spiral closer and closer together, losing energy through gravitational waves until they finally collide. And when they do, the result is a kilonova. This idea made sense on paper, but for years it remained just a theory. Astronomers knew it was possible but had no direct proof. Then, in 2017, that proof finally arrived. If you're finding this breakdown interesting, make sure to hit subscribe. We cover deep space events and cosmic discoveries just like this, and subscribing means you won't miss the next one. The event was called GW170817, and it happened 130 million light-years away, in a galaxy named NGC 4993. First, detectors on Earth picked up gravitational waves, the ripples in space-time caused by the two neutron stars spiraling into each other. The signal lasted over 100 seconds, much longer than a black hole merger. That long chirp was the clue. This was something new. Less than 2 seconds later, telescopes detected a burst of gamma rays from the same patch of sky. That combination was the smoking gun. Astronomers knew immediately this wasn't a black hole collision. It was neutron stars. When neutron stars collide, they eject enormous clouds of matter into space. This material is saturated with neutrons. It's exactly the environment needed for the rapid neutron capture process, or R process. In this process, atomic nuclei rapidly capture neutrons, becoming heavier and heavier until they stabilize as new elements. And this is where gold is born. In seconds, the R process manufactures elements far heavier than iron: gold, platinum, uranium, and dozens more. How do we know this for sure? The key was the changing light from the kilonova. Right after the collision, the explosion glowed blue, which matched the production of lighter heavy elements like strontium. But within days, the light shifted to red and infrared. This wasn't random. The red color comes from the opacity of very heavy elements, metals like gold and platinum, absorbing the blue light. By analyzing the spectrum, astronomers confirmed that the debris contained exactly the kinds of elements predicted by our process models. The match between theory and observation was so precise it closed the case. Neutron star collisions are the cosmic forges of gold. What's even more impressive is the timing. The light and the gravitational waves from GW170817 traveled across the universe for 130 million years, yet they arrived at Earth less than 2 seconds apart. That's how precise the physics is. It's almost like nature set up a perfect experiment to prove the point. The numbers are staggering. The 2017 Kilonova is estimated to have produced gold weighing dozens of times the mass of Earth, along with even more platinum. In one explosion, the universe manufactured more gold than humanity could ever mine from our planet's crust. That gold didn't stay in one place. Over millions of years, it spread out, mixing with interstellar gas and dust. Eventually, some of it became part of the cloud that formed our solar system. That means the gold in your jewelry was forged in a neutron star collision that happened long before Earth even existed. This discovery changed our understanding of the universe. For years, textbooks said gold came from supernovae, but the evidence now shows that the heaviest elements come primarily from kilonovas. It also revealed something important. The same event that produces gravitational waves strong enough to be detected on Earth also creates the metals we value so highly. Gold is not just a commodity, it's a relic of a stellar collision, and it forces us to think differently about our connection to the cosmos. We already knew we were made of stardust, the oxygen in our lungs, the calcium in our bones, the carbon in our cells. But the gold in your ring? That came not from a star's gentle fusion, but from the wreckage of two collapsed suns smashing into each other. So the next time you hold a piece of gold, remember what it really is. Those atoms were forged in the instant two neutron stars collided, in a blast that produced both light and gravitational waves detectable across the universe. Supernovae gave us many of the elements we depend on, but it took kilonovas to give us gold. That's the true story of how this rare metal came to Earth. Not from ordinary stars, but from the wreckage of dead ones. Kilonovas solved the mystery of where gold comes from. They showed us that even in death, stars have a final act, creating the heaviest elements that shape worlds and civilizations. The gold in your possession is a gift from colliding stars. If you enjoyed this explanation and want more clear, simple breakdowns of how the universe works, go ahead and subscribe. It helps support the channel, and you'll always be the first to know when a new video drops.